Okay, good morning, class. So, today we're looking at Euclidean Geometry. And we said that the link to the proof of Theorem 1a can be found in the description box below. Okay. At this point, we have proven the Theorem 1. Okay. So now we're looking at example 1. Example 1 is on page. Just give a marker. 277. Okay. This is examples for exercise 9.1, and this is on page 277. The example. $278. The exercise on page 278. And this example is on page 277.
Yes.
Okay. In example 1, we are told that given AB is a chord of circle center O. D is the midpoint of AB. Okay? AO and DO are joined. AO is equal to 10 centimeters and AB 16 centimeters. The question says calculate OD. So let's calculate this length here. So where do I start? AB, AD, sorry, is equal to 8 units, 8 centimeters. Why? You are given that AD is equal to BD. Okay, so that is 8. Could I have left this out? No, why not? It's not stated on the diagram. Okay? Now what do we do? What do we need? How are we going to calculate OD? We're going to use Pythagoras. But what do I need for Pythagoras? I need a 90 degrees. I need D1 to be 90. So angle D1 is equal to 90 degrees. Why? Bisector from center to chord bisects the chord. Okay. Remember we said that before, so you guys are getting confused. We said that if you are given a circle, okay, and in the circle you have a chord, there's a center, and this is P, Q, R, and these lines are equal. If that's the case, okay, then we can conclude that OR is perpendicular to PQ. Why? Bisector from center to chord. Bisector from center to chord is perpendicular to the chord. Okay? Then the second one is if you got a line that is O, A, B, C, and this is now perpendicular. Then what can you conclude? Then AB is equal to BC. Why? Perpendicular from center to chord bisects the chord. Okay. So if you see in the diagram that is equal, then we know it's 90. If we see in the diagram that is 90, then those lengths are equal. Okay. So coming back here, you said you're going to use Pythagoras, but Pythagoras you need a right angle there. Not so. So do we have enough information to calculate Pythagoras? Yes. So what do we say? OD squared is equal to 10 squared minus 8 squared. Why? Pythagoras. The angle D1 equals 90 degrees. So that's simply going to give us 36, I think. So it's 10 squared minus 8 squared is going to give you 36. The square root of 36 is 6. So that is 16. Alright. Any confusion? No? Now we're going to look at example 2, which is on page 277 as well. So in example 2, we are told given PQ is a chord of circle center O, radius OS. See, now we are given this is 90. So what do we know now? PR is equal to RPY, perpendicular from center to chord by 6 to chord. Okay. Then we are told that PQ cut at R, radius OQ is 25. So if OQ is 25, how much is OS? What's the length of OS? 25. Why? Radian. Okay. PQ is 48. If that's 48, we know that RQ is 24. Perpendicular from center to chord. The question says calculate RS. So can I calculate RS straight away? No. What can be calculated first? OR. Not so. Well, what do I need to know for OR or apply Pythagoras? I need to know that RQ is equal to 24 degrees, 24 units. Why? Perpendicular from center to chord by sec the chord. Okay. Because that's 90, that is of course equal. So there is 24 degrees. So can I calculate Pythagoras here now? Yes. So what do I say? OR squared is equal to 25 squared minus 24 squared. Why? Pythagoras with angle R2 equals 90 degrees. I think that is 49 if I'm not mistaken. 25 squared minus 24 squared. These are Pythagorean triples. Okay. There's going to be 49. That's OR squared. The square root thereof. Of course, we're going to go plus minus, but not in this case. Why? Because we're talking about length, and length is never length. So OR is 7 units. But they haven't answered the question. They want RS or SR. So we know that OS is equal to what? 25. So we now say RS, therefore RS is equal to 25 minus 7. Why? It's the fact that it's your radius. Not so. Okay? Therefore RS is 80 units. So any confusion there? No? So with that you should have been able to do exercise 9.1.